is there a commutative property of the union? Or if you take any two sets A and B, A union B is going to be the same as flipping their positions and saying B union A. Is that going to be true? Well, let's think of some visual examples to see if that's the case. So let's draw our two sets A and B. Let's draw them like this. People first have the instinct to draw them intersecting, but that could be a mistake because sometimes you can miss the example where maybe they don't share any elements. So let's first focus on the simplest case, which is when A and B are very much distinct. They don't share any elements. So what does A union B mean? Well, A union B simply means that we want to consider every single element in A, so we want to highlight everything in A and everything in B. So we're going to highlight everything in B. Okay, fantastic. Now let's ask ourselves about the right-hand side. Let's draw the exact same scenario and follow the rules on the right-hand side. If we have our set A and B, well, B union A simply means we want to consider everything in B and everything in A. And now we want to ask ourselves, do these two pictures look the same? And the answer is, well, yes, they look identical, right? We've just basically, I mean, you can flip these around if the notation's confusing you, but where they are on the whiteboard doesn't matter. They are the same. Okay, so that's true. Now let's try the more conventional thing people oftentimes think of, which is going to be when they intersect. So if you have an example like this, and you want to ask yourself, is that going to be the same as B intersecting with A, right? Or sorry, not intersecting, being unioned with. So A union B means we want to consider everything in A, and then we want to consider everything in B. Okay, so that's what our picture is going to look like. Let's try everything here. Let's try the same thing here. Does B unioned with A look the same? Well, B unioned with A means that we want to consider everything in B, and then we want to consider everything in A. And the answer is yes, these look identical, right? You can flip the names, it doesn't matter. These look identical. So it looks like this statement is in fact going to be true, so let's go ahead and prove it. One more case I forgot to mention that you should always think about is going to be the case where, for example, you have a set A, right? And A is actually completely a subset of B. You have something like this, right? This is your set B. So A is inside of B. So everything in A is going to be in B, but not everything in B is going to be in A. That's what this means. And then we can also think of the reverse, right? Or I guess that's what we're going to do here, so that's going to be identical. So A union B would mean we want to highlight everything in B, which is going to be everything here. And this means that we've automatically highlighted A as well, right? So this is going to be true. And is that going to be the same as, for example, flipping the two around, right? If we first maybe highlighted A, everything in A, and then everything in B. And the answer is yes, these are identical. We've highlighted everything in B. So there we go. You can also flip A and B around. You can make B the smaller one down here and A the bigger one, and you'll see that it's going to be identical as well. Okay, so now we've looked at most cases, and now we can start, now we're confident basically to assume that this is true and try and prove it. So how are we going to prove this? Well, because this is an equality, this means that we have to show everything on the left-hand side is going to be an element of the right-hand side, and everything on the right-hand side is going to be an element of the left-hand side. So that means the following two things have to be true. It must be true that A union B is a subset of B union A, and it must be true that B union A is a subset of A union B. This is how you prove two things are equal. So both of these must be true before we can say that they are the same. So let's go ahead and prove this. Now, because we don't have any restrictions in our A and B, it means it's a for all proof. It's for any two sets A and B. They could be the same, they could be different. Oh, that's the other case I guess you could have thought of, is you could have written down something like this, right? And then B's over A and B, they're equal. So then this would be the same as our proof that looks like this, right? If A is equal to B, then it's the same as saying this, which is obviously true. So that's the other case I didn't think of. But because this is a for all proof, we're going to start with a let. So we're going to say let, and what are we going to let? We're going to let A and B be sets, just so the reader knows what we're talking about when we say A and B in capital letters. Okay, now let's try and prove our first case. The first case we're going to try and prove is that the left-hand side is a subset of the right-hand side. And how are we going to do this? Well, we're going to want to start by saying A union B, and we're going to want to get from here to our goal, which is to show that this is going to be a subset of B union A, right? We're going to start here and show it's a subset of this. How are we going to do that? Well, for this to be a subset of that, it must be that every element here must be in here. So what are we going to do? Well, we're going to say, let's create some representative element. We're going to say, let's create X. X is going to be a representative element of A union B. Everything in A union B can be X. And then we want to show that if X can also be an element of B union A, then it must be that because this represents everything here, and it's also in here, that means everything in here is going to be here, which makes this a subset of that. Fantastic. So how are we going to do this? Well, first we can break apart what it means when we say A union B. This simply means the two following things. It means X is an element of A, or X is an element of B. Fantastic. And then where can we go from here? Well, we can say because it's either in B or in A, we can say that this makes it an element of B union A, which then gets us there. We could say for X to be an A, that means it's going to be a part of X is an element of B union A. So there we go. This is going to be the sketch of our proof. We're going to break this apart and say that that means this must be true. And when this is true, these two are true. And if these two are true, then this is true for all X, which means that this is going to be a subset of that. So let's write that down in words. We're going to first start by supposing our representative element. We're going to say, suppose X is an element of A union B. Fantastic. Next, we're going to say, then this must mean that X is an element of A, or X, or maybe I'll write this in the line below. Then X is an element of A, or X is an element of B. Fantastic. Then we're going to want to break this down into just two tinier categories like we have here. We're going to say if X is in B, then X is an element of B union A. And then we're going to say if X is in A, then X is an element of B union A. Fantastic. So X is an element of B union A regardless, making what we wanted to prove to be true, making A union B a subset of B union A. Fantastic. So we've proven the first case is true. Now let's go ahead and try and prove the second case. So how are we going to prove the right-hand side is a subset of the left-hand side? Well, we're going to want to start with the right-hand side and get to the left-hand side. We're going to use the same strategy. We're going to want to show that some representative element, in this case I'm going to choose Y, is going to also be an element of our goal. It's going to be an element of what we want to show it's a subset of. So how are we going to do that? Well, I want to break this apart. When we say B union A, when we say Y is an element of that, we mean Y is an element of B or Y is an element of A, right? It could be an element of both or just one of the two. Fantastic. So from here, what can we say? Well, we can say for Y to be an element of A, then Y can be, well, actually, I guess we can just draw a straight arrow here, then Y can be an element of A union B. Similarly for Y, if Y was in B. If Y was in B, then Y would definitely be an element of A union B. Great, so this is going to be our sketch. Now let's try and put this into words. So what are we going to do? We're going to first start by supposing an arbitrary element to represent all of the elements in our set here. So we're going to say, suppose, and we'll use Y, suppose Y is an element of B union A. Fantastic. Then we're going to want to break apart what this means. So this means that then Y is an element of B, or I think I'll keep up with the pattern I did here where I wrote that in the next time. We're going to say then Y is an element of B, or Y is an element of A. Fantastic. Now we're going to say, well, let's take the case where it's in B. So we're going to say if Y is in B, then Y is definitely going to be an element of B union A. Fantastic. Similarly, we're going to do the same thing for A. If Y is in A, then Y is going to be an element of A. Oh, right, yeah, made a mistake. A union B, that's what we're trying to show from this. So A union B. There we go. So if y is B, then it's an element of A union B. If y is A, then y is an element of A union B. Fantastic. And now we're going to say, so y is an element of A union B regardless, making what we want it to prove to be true, making B union A a subset of A union B. Fantastic. So we've shown both cases are going to be true. So now all that's left is to write our conclusion, right? So we're going to say, let me sit down here since we're writing pretty low now. Oh yeah, my writing's gotten a little skewed. So we're going to say, in conclusion, given A union B is a subset of B union A, and B union A is a subset of A union B, then A union B is equal to B union A. Fantastic. We have proven our statement up here to be true.